everyone, welcome to our AI full course by Simplilearn. What if you could teach machines to chat, write, draw, and even build apps just like humans? Sounds wild, right? Well, that's the power of AI today. And everyone from tech companies to healthcare, finance, and creative industries is craving AI skills. Whether you want a high-paying job, plan to start your own AI project, or simply want to understand how it all works, diving into AI is one of the best moves you can make. This course is designed to be practical, beginner-friendly, and super exciting. You'll start with the basics of AI and machine learning, then explore powerful topics like large language models, RAG, transformers, multimodal AI, reinforcement learning, and AI bias. You'll also get to build real projects from AI-powered websites to iOS app and even your own AI clone. Plus, we have covered the top AI skills to help you earn money and introduce you to the best tools developers are using right now. No jargon, no boring theory, just hands-on real-world AI made easy for you. Let's dive in and build the future together. Just a quick information, guys, before we begin, if you're interested in growing your career in AI and machine learning, this course is a great way to start. The Professional Certificate in AI and Machine Learning by Simplilearn, Purdue University Online, and IBM help you master key AI skills like ChatGPT, LLMs, deep learning, and agentic AI through live classes and hands-on projects. So in just 6 months, you'll work on real-world industry projects and use 18 plus popular tools like Python and TensorFlow, and even earn certificates from Purdue and IBM. So what are you waiting for? Hurry up and enroll now, and you can find the link below. So let's get started.
Welcome to Artificial Intelligence Tutorial. My name is Richard Kirshner. I'm with the Simplilearn team. That's www.simplilearn.com. Get certified and get ahead. What's in it for you today? What is artificial intelligence? So we'll start with a general concept. Types of artificial intelligence, covering the 4 main areas. Ways of achieving artificial intelligence. And some general applications of artificial intelligence in today's world. Finally, we'll dive into a use case predicting if a person has diabetes or not. And we'll be using TensorFlow for that in the Python environment. What is artificial intelligence? In today's world, it's probably one of the most exciting advancements that we're in the middle of experiencing as humans. So, what is artificial intelligence? And here we have a robot with nice little clampy hands. Hey, what am I? You are what we call artificial intelligence. I am your creator, reminding him who programmed him and who he's supposed to take care of. Artificial intelligence is a branch of computer science dedicated to creating intelligent machines that work and react like humans. In today's place where we're at with artificial intelligence, I really want to highlight the fact that they work and react like humans, because that is where the development of artificial intelligence is, and that's what we're comparing it to, is how it looks like next to a human. Thanks. Any tasks you want me to do for you? Get me a cup of coffee? Poof, here you go. And he brings him a cup of coffee. That's my kind of robot. I love my coffee in the morning. You'll see there's kind of a side theme of coffee today's tutorial. So here we have a robot that's able to bring him a cup of coffee. It seems pretty far out there, you know, that we have a walking robot that's doing this, but it's not as far out there as you think. We have automatic coffee pots. We have devices that can move an object from one point to the other. You know, anything from Amazon delivering packages or whatever you want. All these things are in today's world. We're right on the edge of all this. That's what makes this so exciting. Such an exciting topic and a place of study. So let's take a look, a real general look at types of artificial intelligence in the really big picture. I mean, when we drill into it, there's like machine learning and all kinds of different aspects, but just a generic level of artificial intelligence. So, hi there, discovered 4 different types. Come have a look. So we have our kind of Einstein-looking guy or professor at some college. So the very first part that we're really, this is reactive machines. They've been around a long time. This kind of AI are purely reactive and do not hold the ability to form memories or use past experiences to make decisions. These machines are designed to do specific jobs. Remember I talked about the programmable coffee maker that makes coffee in the morning? It doesn't remember yesterday from tomorrow. It runs its program. Even going back to our washing machines, they have automatic load balancers that have been around for decades. So reactive machines, we program to do certain tasks, and they have no memory, but they're very functional. Then we have limited memory. And this is kind of right where we're at right now. This kind of AI uses past experience and the present data to make a decision. Self-driving cars are kind of limited memory AI. We bring up self-driving cars because that's a big thing, especially in today's market. They have all these images that they brought in and videos of what's gone on before, and they use that to teach the automatic car what to do. So it's based on a limited memory. Limited memory means it's not evolving new ideas. They have to actually, when they need to make a change, they have the program built on the memory, but then they have to make those changes outside of that and then put the new setup in there. So it's continually reprogramming itself. Theory of mind. These AI machines can socialize and understand human emotions. Machines with such abilities are yet to be developed. Of course, that's under debate because there's a lot of places that are working on the theory of mind and having it be able to cognitively understand somebody based on the environment, their facial features, all kinds of things, and evolve with them. So they have some kind of reflective ability to evolve with that. And finally, self-awareness. This is the future of AI. These machines will be super intelligent, sentient, and conscious. So they'll be able to react very much like a human being, although they'll have their own flavor, I'm sure. Achieving artificial intelligence. So how in today's world right now are we going to achieve artificial intelligence? Well, the main arena right now is machine learning. Machine learning provides artificial intelligence with the ability to learn. This is achieved by using algorithms to discover patterns and generate insights from the data they are exposed to. And here we have a computer as we get more and more to the human realm of artificial intelligence. You can see this guy splits in two and he's inside his hidden networks and machine learning programs. Deep learning, which is a subcategory of machine learning. Deep learning provides artificial intelligence the ability to mimic a human brain's neural network. It can make sense of patterns, noise, and sources of confusion in the data. Let's try to segregate different kinds of photos using deep learning. So first we have our pile of photographs, much more organized than my boxes in my closet of photographs. The machine goes through the features of every photo to distinguish them. This is called feature extraction. Bingo, it figures out the different features in the photos. And so based on those different features, labels the photos, it says these are landscapes, these are portraits, these are others. So it separates them in there. And if you've ever been on Google Photos, a favorite of mine, I go through there and I type in dog and I get all the images of my dog. It's pretty amazing how it's able to pull those features out. So when we're achieving artificial intelligence and the deep learning, let's take a closer look and see just how deep learning works. There are a lot of models out there. This is the most basic model used. This is a neural network. There are three main layers in a neural network. The photos that we want to segregate go into the input layer. And so we have a picture of Mona Lisa, it looks like, and a couple of people. When it goes into the first input layer, the arrows are drawn to like individual dots. Each one of those white dots in the yellow layer or in the input layer would be a pixel in the picture, maybe, a value for that pixel. So the picture of the mountains goes in there and it fills in that whole input layer. And then the next picture of the nightscape goes in there. The hidden layers are responsible for all the mathematical computations or feature extraction on our inputs. So when you see here, we have the two kind of orangish red layers here, and there's all these lines in there. Those lines are the weights. Each one of those represents usually a float number or a decimal number. And then it multiplies it by the value in the input layer. And you'll see that as it adds all these up in the hidden layer, each one of those dots in the hidden layer then has a value based on the sum of the weights. And then it takes those and it puts it into another hidden layer. And you might ask, well, why do we have multiple hidden layers? Well, the hidden layers function as different alternatives to some degree. So the more hidden layers you have, the more complex the data that goes in and what they can produce coming out. The accuracy of the predicted output generally depends on the number of hidden layers we have. So there we go. The accuracy is based on how many hidden layers we have. And again, it has to do with how complex the data is going in. The output layer gives us the segregated photos. So once it adds up all these weights, and you'll see there's weights also going into the output layer, based on those weights, it'll say, yes, it's a portrait, no, it's a portrait. Yes, it's a landscape, no, it's a landscape. And that's how we get our setup in there. So now we're able to label our photos. Let's take a look and see what that looks like in another domain. We have photograph domain. Now let's look at it in the airline ticket. So let's predict the airline ticket prices using machine learning. These are the factors based on which we're going to make the predictions. And choosing your factors is so important. But for right here, we'll just go ahead and take a look at what we got. We have airlines, we have the origin airport, the destination airport, the departure date. Here are some historical data of ticket prices to train the machine. So we pull in the old data. This is what's happened over the years. Now that our machine is trained, let's give it new data for which it will predict the prices. And if you remember from our 4 different kinds of machines, we have machines with memory. Well, this is the memory part. It remembers all the old data and then it compares what you put in to produce the new data, to predict the new prices. The price is 1,000. That's an expensive flight. Of course, if that is US dollars, if it's India, I don't know what the price range is on that. Hopefully it's a good deal for wherever you're going. So we predict the prices, and this is kind of nice because if you're looking way ahead, it'd be nice to know if you're planning a trip for next year, how much those tickets are going to cost, and they certainly fluctuate a lot. So let's take a look at the applications of artificial intelligence. We're going to dive just a little deeper because we talked about photos, we've talked about airline ticket prices, kind of very specific, you get one specific number. But let's look at some more things that are probably more in-home, more common right now. Speaking of in-home, this young gentleman is entering his room. Of course, makes a comment like we all do when we walk into a room. This room is dark, isn't it? Let's see what happens when I enter it. The sensors in my room detect my presence and switch on the lights. This is an example of non-memory machines. Okay, it senses you. It doesn't have a memory of whether you've gone in or not. Some of the new models start running a prediction as to whether you're in the room or not, when you show up, when you don't. So they turn things on before you come down the stairs in the morning, especially if you're trying to save energy. You might have one of those fancy thermostats, which starts guessing when you get up in the morning so it doesn't start the heater until it knows you're going to get up. So here he comes in here, and this is one of the examples of a smart machine. And that is one of the many applications of artificial intelligence, one of the things we're developing here in our homes. Okay, bye. Abruptly he leaves, leaving his nice steaming cup of coffee there on the table. And when he leaves, the sensors detect he's gone and turn off the lights. Let's watch some TV. Did someone say TV? The sound sensors on the TV detect my voice and turn on the TV. Sounds kind of strange, but with the Google dongle and a Google Home Mini, you can actually do just that. You can ask it to play a movie downstairs on your downstairs TV. True also with the Amazon Fire Stick and all the different artificial intelligent home appliances that are coming out. Pretty amazing time to be alive and in this industry. Here you have one more application of artificial intelligence, and you can probably think of dozens of others that are right now on the cutting edge of development. So let's jump into my favorite part, which is a use case. Predict if a person has diabetes. And in the medical domain, if you read any of these, they say predict if a person has diabetes. But in the medical domain, we would want to restate this as, what is the risk? Is a person a high risk of diabetes? It should just be something on their radar to be looking out for. And we'll be helping you out with the use case. There we are with our cup of coffee again. I forgot to shave, as you can see. We'll start with the problem statement. The problem statement is to predict if a person has diabetes or not. And we might start with this prediction statement, but if you were actually using this in a real case, again, you would say you're high risk of diabetes would be the proper way to present that to somebody if you ran their test data through here. But that's very domain specific, which is outside of the problem statement as far as a computer programmer is involved. So we're going to have a look at the features. These are the things that have been recorded, and they already have this data from the hospitals. One of them would be number of times pregnant. Obviously, if you're a guy, that'd be 0. Glucose concentration. So these are people who've had their glucose measured. Blood pressure. Age. Age is a big factor, an easy thing to look at. Insulin level. So if someone's on insulin, they probably have diabetes. Otherwise, they wouldn't be taking insulin. But that would affect everything else, and we add that in there if they're using insulin. Let's start off with the code. So we're going to start off by importing parts of our data set. And if we're going to do this, let's jump into one of our favorite tools. We're going to use the Anaconda Jupyter Notebook. So let me flip over to there and we'll talk just briefly about that, and then we'll look over this code. So here we are in the Jupyter Notebook, and this is an inline editor, which is just really cool for messing with Python on the fly. You can do demos in it. It's very visual. You can add pieces of code. It has cells, so you can run each cell individually. You can delete them. You can tell the cell to be a comment. so that instead of running it, it just skips over it. There's all kinds of cool things you can do with Jupyter Notebook. We're not going to go into that. We're actually going to go with the TensorFlow. And you do have to import all the different modules in your Python. Now, if you're in a different Python IDE, that's fine. It'll work in just about any of your Python IDEs. And I'll point out the one difference in code when we get to that, which is the inline for doing our graph. And in this code, we're going to go through, we're going to load our data up, we're going to explore it, we're going to label it, and then we'll use the TensorFlow, and then we'll get down to the end where we're going to take a look at how good the model is. Does it work? So let's start with the top part here. And let me go ahead and let's paste that code in there. I've added a line in at the top. I've added the folder, because I didn't put it in the same folder as the program that's running. You don't need to worry too much about that, but if you have a folder issue or it says file doesn't exist, you probably have it in the wrong folder, or you need to add the folder path. And then we're going to import pandas. And let me just, one of the cool things, since it's in Chrome, we can just do that Control plus and zoom right in there. And we have the import pandas as PD. So go ahead and draw a line in there. You can see that the pandas as PD, add a little drawing thing in there to make it a little easier to see. Pandas is a data set. It's a really nice package you can add into your Python. Usually it's done as pandas as PD. That's very common to see the PD here. Let's circle that. It's basically like an Excel spreadsheet. It adds columns, it adds headers, it adds a lot of functionality to look at your data. And the first thing we're going to do with that is we're going to come down here and we're going to read. And this is a CSV. It's a CSV file. You can open up the file on your computer if you want. If you need access to the file, you can either search it and download it from the main thing, or type a note in down below on the YouTube video. And Simplilearn will help you get that file also. And that's true of any questions you have on this. You can add comments down there, and somebody at Simplilearn actually keeps an eye on that, and we'll try to answer those questions for you. I put in the full path. You don't have to if you have your data file saved in the same folder you're running your program in. And this is just a CSV file, comma separated variables. And with the pandas, we can read it in there, and we're going to give it, put it right in a variable called diabetes. And then finally we take diabetes, and you'll see diabetes.head. This is a pandas command, and it's really nice because it just displays the data for us. Let me go ahead and erase that. And so we go up to the run button up here in our Jupyter Notebook, which runs the script in this. That's the cell we're in. And you can see with the diabetes.head, since it's a pandas data frame, it prints everything out nice and neat for us. And this is really great. And if I go ahead and do a control minus, I can get it all to fit on the same screen. And this is the first 5 lines. When you do the head of the data, it just prints out the first 5 lines. In programming, of course, we start with 0. So we have 0, 1, 2, 3, and 4. Here we go. Here we go. We start with 0. We have 0, 1, 2, 3, and 4. We have our titles going across the top. And of course, the first column is number of pregnancies, glucose concentration for the second one, blood pressure, measurements of triceps. As we keep going, you'll see, you can guess what most of these things are. Group, I'm not sure, this is probably the test group. I didn't look it up to see specifically what that is. Anytime you start exploring data, and for this example, we don't really need to get too much in detail, you want to know the domain. What does this information mean? Are we duplicating information going in? That's beyond the scope of this. For right now, though, we're just going to look at this data, and we're going to take apart the different pieces of this data. So let's jump in there and take a look at what the next set of code is. So in our next setup, or our next step, we got to start looking at cleaning the data. We got to start looking at these different columns and how are we going to bring them in? Which columns are what? And I'm going to jump ahead a little bit, and also as we look at the columns, we're going to do our import our TensorFlow as TF. That's a common import, but that's our TensorFlow model. TensorFlow was developed by Google, and then they put it into open source so that it's free for everybody to use, which is always a nice thing. So let's take a look at what these 2 steps look like in our Jupyter Notebook. So let's paste this code in here, and this is something that happens when you're messing with data, is you'll repeat yourself numerous times. We already have diabetes head, so I'm going to put the little pound sign, which tells Python that this is just going to be a comment. We're not going to run it a second time. In here we have diabetes.columns, and then diabetes columns to norm equals diabetes columns to norm.apply lambda x. Let's talk about that, but let me first run that, and let's see what that comes out with that. And then let's put the next set of code in also. And I'm going to run that. Let me just hit the run button. It doesn't really have an output, but we did a lot of stuff here. So let's go over what we did on this. So I've turned on my drawing implement to help go through all this, because there's a lot going on here. The first thing is we have all of our columns up here, all of our column names. Let me just highlight that and draw a circle around that like we did earlier. And we want to look at just specific columns. And we're going to start, let me change the color on this so it really sticks out. I'll use like a blue. I'm going to look at these columns. And we're not going to do age, class, or group. We're going to look at those in a different way. And I'll explain in a little bit what that's about. So we're looking at number of pregnancies, basically anything that can be read as a float number. And you might say age could be read as a float number. We're going to address that differently because when you're doing statistics, we usually take the ages and we group them into buckets. And we'll talk about that. And so we're going to take these columns and we're going to do what they call normalize them. Column to normalize. What is normalize? If you're using the sklearn module, one of their neural networks, they call it scaling or scalar. This is in all of these neural networks. What happens is if I have two pieces of data, and let's say one of them is, in this case, 0 to 6, and one of them is in insulin level is 0 to maybe 0.2 would be a very high level. I don't know what they actually go to. A neural network will look at this 6, and it'll go 0 to 6, and as you get into 0, 6, here's an 8, even a higher number, it will weight those heavier. And so it'll skew the results based more on the number of pregnancies than based on the insulin or based on the blood pressure. So we want to level the playing field. We want these values to all be in the same area. We do that by normalizing it here. And we use a lambda function. This is always a kind of a fun thing. We take the diabetes. It's a panda setup, and let me just erase all that so we can go down here, put it back to red. And we take our diabetes, which is a panda data set, and we only want to look at the columns to normalize, because that's what we built. We built a list of those columns, and we're going to apply a lambda function. And you'll see lambda in all kinds of Python programming. It just means it's a function. We put x in, and whatever is outside of the x over here, it then takes that and returns that value. So the new value is going to be whatever x is minus x min. Again, it's a pandas data set, so we can get by with that, which is really cool. It makes it easy to read. So we take x, we look for the minimum value of x, and then we divide that by the maximum value of x minus the x min, or the width. And what this essentially does is if you're going from 0 to 15, it's going to divide by 15, and then we subtract it. Let's make this 2 instead of 0. Or 20 to 115. There we go. First off, we set this to 0. So we subtract x min. So right off the bat, the minimal value is going to be 0. And then we divide it by the difference here, x min minus x max, or x max minus x min. This basically sets all the values between 0 to 1. And that's very important if we want to make sure that it's not going to be a skew in the results, if it's not going to weight the values one direction or the other. 0 to 1. That's what this is doing. And again, there's like so many different ways to scale our data. This is the most basic scale, it's standard scaling, and it's the most common. And we spelled it out in the lambda. There's actual modules that do that, but lambda it's such an easy thing to do, and you can really see what we're doing here. So now we've taken these columns, we've scaled them all, and changed them to a 0 to 1 value. We now need to let the program know, the TensorFlow model that we're going to create, we need to let it know what these things are. So to do that, I create a variable called number pregnancy, keep it simple, and we've imported the TensorFlow as TF. One line of code brings our TensorFlow in for us. Awesome. Love Python. So you get number of pregnancies and tf.featureColumn.numeric column. We're going to tell it's a numeric column, so it knows that this is a float value, 0 to 1, and then number underscore pregnant. So we're taking that column and we've reshaped that column from 0 to 1. And no, that doesn't mean you have a 0.1 pregnancy. It just means 0.1 equals 1 or something. Number pregnant. So we're just mapping this data. So TensorFlow knows what to do with it. And we go through all of these. We go through all the way up to, again, we're not doing age. Let me just separate age down here. These have all been adjusted. Age, we're going to handle differently. We still put it as a numerical column because it is. So let me just circle age. And group, we didn't even touch group yet. We're going to look at group and age, and we're going to do some special stuff with that. Class, we're going to look at last. Why? Because this is whether they have diabetes or not. That's what we're testing for. So this is our history. We know these people have diabetes or not, and we want to find out, we want to create a model, and then we want to test that model predicting whether somebody new has diabetes or not. So here I am still with my cup of coffee working away, refill number 3. Let's explore both the categorical group, which is going to be the A, B, C, and D on the end, and also the age. We're going to talk about those a little bit more. And then we're going to combine all those features and we'll jump into splitting the data, although that's kind of the next step. But we'll put that all together. What are we doing with the age and what are we doing with the group down there? So let's flip on over and take a look at our Jupyter Notebook. So the first thing is let's put this new set of code in here and run it. And let's talk about what we're doing on this set of code. And I actually want to go one more step forward on the next set of code, or part of it. There we go. And I can go ahead and just run that while we have it. That's fine. Let's just scroll up a little bit here and let's go through what we just did with this set of code. If we go back up here to the top part, we have group B, C, B, B, C. We learned from the header. So when I come down here, we're going to create assigned group. And let me get my drawing pad out. So we're looking at this first one up here, assigned group, TF feature column, categorical column with vocabulary list. Whew, that is a mouthful. This is saying that this is a categorical list. In this case we have A, B, C, D. You see this a lot in TensorFlow. A lot of times TensorFlow is used to analyze text or logs, error logs, and they're just full of all this information, and they take these, in this case A, B, C, D, but in other cases it'd be words, and they create numbers out of them. So it has 0, this is one column, this is another column, this is another column, this is another column. And it's just this way of being able to look at this in a different light and assigning them different values. You really don't want to assign this a float value. First thought might be, let's assign this 0 to 3, 0, 1, 2, 3 for A, B, C, D. But if you did that, it would try to add 1 plus 2 to get 3 as part of its math and functions. And that just isn't true. C does not equal A plus B. C is just a categorical name. It could have been the Frank group and Laura's group and Abid's group, but it's not. You know, they're not float numbers. So very important that you have that distinction in your data. The next step we're looking at is our matplot. And we're going to do this. This is a cool, useful tool. We're going to import matplotlibary.pyplot as PLT, a standard import. And this next line here is really important. We're doing the matplot library. We want it to be inline. That's because we're in a Jupyter Notebook. Remember I told you before that if you're running this in a different IDE, you might get a different result. This is the line you need if you want to see the graph on this page. And then we do diabetes, and we're going to look at just the age, and .hist bins equals 20. What the heck is that? Well, it turns out that because this is, remember it's a pandas, there's our PD, pandas as PD. Because this is a pandas, panda automatically knows to look for the matplot library. And a hist just means it's going to be a histogram. And we're going to separate it into 20 bins. And that's what this graph is here. So when I take the diabetes and I do a histogram of it, it produces this really nice graph. We can see that at 22, most of the participants in this, probably around 174 of the people that were recorded, were of this age bracket. They're right here in this first column here. And as they get further and further down, they have less and less and less until when you're at 80, you can actually see down here there's almost none in a couple of these categories. And this is important to note because when you're doing census, you know, the older the group is, the more the people have passed away. So you're going to have this in any of your censuses you take. You're always going to have a much larger group in the younger crowd, and then it gets lower and lower as they get older. And I mentioned the word buckets. Here we go. We're going to create an age bucket. We're going to put people in buckets. Can you imagine people sitting in buckets? Kind of a funny way of looking at it. This just makes it easier for us to separate it. When I go to the doctor's office, I don't want to be told, well, you're age 22. This is your, you know, you'll get a decent one at 22. Here we are back to my cup of coffee. I told you coffee was an underlying theme. These next couple steps are very specific to TensorFlow. Up until now, we had some TensorFlow as we set the categories up, but you'd have to set that up with any model you use to make sure they're set correctly. They'd be set up a little differently. But we run input functions. And in TensorFlow, this allows for some really cool things to happen. And this is why TensorFlow is so predominant in a lot of areas. So let's take a look at these next couple lines of code here. We're going to create the input function, and we're going to go ahead and create the model. And let me go ahead and put these codes in here. I went ahead and split it up so it has different lines, so we can talk a little bit about that. And then the actual model. And let me go ahead and run this so we can see what that looks like. And in my particular environment, it just prints out a little bit of information about the model. Not too worried about looking at that, but we do want to take a closer look at what we did here. So we've created an input function. And again, this is very specific to TensorFlow. With the input function, we have our train. We have our x equals x train and our y equals y train, because we want to train it with the particular information. But we have these other settings in here, these two settings. And the number of epochs is how many times it's going to go over our training model. Epoch means large, it means all the data. So we're going to go over it 1,000 times. That's actually a huge overkill for this amount of data. Usually it only needs probably about 200, but you know, when we're putting it together and you're trying things out, you just kind of throw the numbers in there and then you go back and fine tune it sometimes. The batch size is really important. This is where TensorFlow does some really cool things. If you're processing this over a huge amount of data and you try to batch everything at once, you end up with a problem. This means we're only going to read 10 lines at a time through our data. So each one of those rows of testing they've done, we're only going to look at 10 of them at a time and put that through our model and train it. And then shuffle is self-explanatory. We're just randomly selecting which data and what order we go in. That way, if there's like, 5 in a row that are kind of weighted one way and vice versa, it mixes them up. And then finally we create our model. So the model goes in there and goes, okay, I have a tf.estimator.linear classifier. We're going to put in the feature columns equals feature columns. We defined all our columns up above. And then we have in classes equal 2. And that just means we have our out result is 0 or 1. You have diabetes or you don't have diabetes, or in this case we actually call it high risk of diabetes. And then I put one more line of code in there, which I forgot. We've set up our model. We set up our feature columns. Now we need to actually train it. Model.train. You'll see this so common in so many different neural network models. This is like a standard. What's different though is we have to feed it the function. Remember, we created this function with all this information on it. And then we have steps. And steps is similar to number of batches and batch size. It's more like individual lines we step through. 1,000 is a lot more common for steps than epochs. But steps is used. You could probably leave this out in this particular example. And let's go ahead and run this all together, because it has a slight, when we start training it, we get a different output. So here we go. I've run it. It's given me the information from when I created the model. And now it just starts going through and we get this information. Tensor loss equals global step. All kinds of stuff going on here. And if you're following this, it's just going through the steps and training it. It gives you information. You could dig deep into here, but for this particular setup, we're not going to go too deep on what's going on. Just know that we've trained our model. This model now has the information we need in it to start running predictions. So as we sip our next, take our next sip of coffee, or maybe it's tea, or if you're one of those strange late night workers, maybe it's a sip of wine. We go into the next step and we actually want to run some predictions on here, but we don't want to run the training. We want to run the test on there. We want to take our test data and see what it did. And so that's what we're going to do next, is we're going to run the test through and actually get some answers. So if you were actually deploying it, you would pull the answers out of the data it's bringing back. Let's take a look at that in our Jupyter Notebook. So here we go. Let's paste it in there. I'm going to go ahead and run it. And you'll see that as it goes, it's actually putting the answers out. And if you remember correctly, well, we'll walk through this here in just a second, but it goes through and it runs each line and it gives you a prediction for each line one at a time and prints them out. So let's take a look and see what that actually looks like. Let's start with this first part. We've created another function. This is just like the other function, except for x equals x test. And there's no y. Why is there no y? Because we don't know what the answer is on this yet. We don't want to tell it the answer. We want it to guess what the answer is, so we can evaluate that and see how good it did on that 33% of the data. So this is our X test. Batch size is 10 again. So if we were watching this roll down here, we would see that it actually processes it 10 lines at a time. It's only going to go through once. It goes through all the X test data one time. We don't need to have it predict multiple times. And shuffle equals false. Very important we set the shuffle to false, because if we were tracking this and actually giving people answers, we'd want to make sure it connects to the right person so they get the right results. But of course, we're just doing this to evaluate it. So let's take a look down here what it put out. And as I scroll down to my Jupyter notebook, we have some information as far as the TensorFlow running and then the actual output. And if we look at the output, we know by this first bracket in Python it's an array. We know by this squiggly bracket that this is a dictionary, so that this is a label. The dictionary has logistic, probabilities, class IDs, classes, and so this whole first part, let me redo that. This whole first part is one output, and we know that because there is the bracket there, and there is this bracket here for the dictionary. And it's a dictionary of terms. So if I pulled this out and I looked at object 0 in here, I would go down to, and let me just find it, here it is, classes. Remember how we define classes? We define classes as our answer. And so it's guessing, our TensorFlow says, based on all the information you gave me, I'm guessing this first entry of our first test data is high-risk diabetes. Uh-oh, go get tested. Change your diet. Watch what you're eating. You know, high risk, 1. And if we go down far enough, we can see down here is another one where classes equals 0. I skipped a couple because they're all 1s up here. The B, this particular output, B, in front of the 1, means it's a binary output. It only comes out as 0 or 1. And there's a lot of other information in here. You can dig deep into TensorFlow and explain these different numbers. That's way beyond the scope of what we're working on today. So the basics of it, though, is you get an output. And we have an output of whether the person has diabetes or not. Well, in this case, it's high risk of diabetes or not. So now that we've run our predictions, take a sip of coffee, a short break, and we say, well, what do we need to do? Well, we need to know how good was our predictions. We need to evaluate our model. So if you're going to publish this to a company or something like that, they want to know how good you did. Let's take a look at what that looks like in the code. So let's paste that in here, and just real quick, go back over this. By now, this function should look very, we're going to call it eval input function. It should be pretty straightforward here. We have our TF estimator inputs, pandas input function, and then we have our X test, our Y test. So this time we want to give it the answer so it has something to see how good it did on. Batches 10, processing 10 at a time. We're only going to go with once through the data. We're not shuffling it, although it doesn't really matter with this. And then we're going to do results equals model.evaluate. And we put our evaluation function in there. This should all look familiar because we're repeating the same thing. It's very similar with a couple different changes as far as what we're feeding it and the fact that we're doing an evaluation. Let's see what that looks like when we run it. And we go up here to our run model. You'll see warnings on some of these because I didn't install this on its own install. So a lot of it is just temporary files because I'm using the Jupyter notebook instead of setting it up on a regular machine. And we get our output, and we'll go ahead and just look at this output real quick, and then we'll flip over. And from here you'll see that it generates an accuracy, a baseline, average loss, the mean, gives you precision, prediction. It gives you all kinds of information on here. So let's flip over and see what's important, and we'll look at the slide. Here we are in this slide, and this should be exciting because we just about wrapped up our whole TensorFlow, and TensorFlow is one of the more complicated models out there. So give yourself a pat on the back for getting all the way through this. When we look at this output, we have an accuracy of 0.7165. That's really what we want to look at. That means that we have an accuracy, if you're just truncating it, of 71%. That's quite good for our model. You know, given a small amount of data, we came up with the 71% of letting people know they're high risk or not with diabetes. So we created a model that can predict if a person has diabetes based on some previous records of people who were diagnosed with diabetes. And we managed to have an accuracy of 71%, which is quite good. The model was implemented on Python using TensorFlow. Again, pat yourself on the back because TensorFlow is one of the more complicated scripts out there, but it's also one of the more diverse and useful ones. So the key takeaways today is we've covered what is artificial intelligence with our robot that brings us coffee, and we noted that we are comparing it to how it reacts and looks like humans. Very important to note that in today's world and where we're at. And we looked at types of artificial intelligence from the reactive machines to limited memory and looking into the future of theory of mind and self-awareness. And then we went in there and took a look at taking photos and how artificial machine learning work. We took a glance at deep learning with our neural networks and how we have hidden layers in our input layer and our output layer. We then looked at a use case of somebody walking into a room and activating their TV using artificial intelligence, or part of the AI category. And finally, we dug in deep and we did some coding in the TensorFlow in Python. We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. This is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under quiz time, and we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring setup there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning, and if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is, and what a triangle is, and what a square is, it goes in there, looks at them, and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store and not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future, it's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now we're starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data, we have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance. In our head, we can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two, but let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time. And we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time, 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with the mean value of y of I equals 2.8. Where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in, and we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, I, j, q, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you could imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning and not a good day in the afternoon or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. 2 important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of and N, where P is the probability that you're going to play a game of golf, and N is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of P over P plus N minus N over P plus N times the log squared of N of P plus N. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the data set is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, You can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other 3 attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy, if it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the 2 groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the 2 points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is Mel. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a three-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just 2 features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. And they usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, so you have different ways of referencing it, easily viewing it, and there's additional features you can run on a data frame. And Pandas kind of sits on numpy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn, we're going to use the sklearn model, import SVM, support vector machine. And then As a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human, but if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use two packages. We're going to import matplotlibary.pyplot as PLT, again very common, and we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on NumPy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your %sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and pip, use the PIP or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, .read CSV. Remember, it's a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And Pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So Pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data. And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the two different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn in doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into two parts. We need a type label, and remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake. It knows 0 and 1. So what we're going to do is we're going to create a type label, and from this we'll create a numpy array np where, and this is where we can do some logic. We take our recipes from our panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list, and this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features, make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do, but for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them, but we're going to do just flour and sugar. And we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients. And you can see what that looks like. And so we have just the amount of flour and sugar, just the 2 sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything. We just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that and you'll see it's just the 2 columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. And in this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value or whatever you're trying to work on. And SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar. And the type label, is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, we split it into training data and test data. And they even do something where they split it into thirds, where a third is used for, where you switch between which one's training and test. There's all kinds of things that go into that, and it gets very complicated when you get to the higher end. Not overly complicated, just an extra step which we're not going to do today because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear, and there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say we're going to use a W for our variable on here. We're going to do model.coefficient _0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent 2 different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in 2-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's 2 different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about numpy. So when I do a times xx, which is a whole numpy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup. And YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you wanted to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so it's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborne plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborne sits on top of pyplot, we can do the pyplot for the line going through. And that is simply plt.plot. And that's our XX and YY, our two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the pyplot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data. And you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through. And we'll create a function with def. And let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0, so we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in, and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if we're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. There we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do PLT plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come out. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin, which wraps up our cupcake versus muffin. Today,
large language models, LLMs. If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that power search engines, LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By the end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So what are the large language models? Large language models like ChatGPT 4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant applications, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what are large language models used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how are large language models trained. Large language models typically undergo pre-training on a board, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning face for specific tasks. So there are some training processes of LLM which involves several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the next. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a syntax. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique. This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iterations or epochs until the model's output achieve a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of applications across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news website or streaming services. So these applications highlight the potential impact of large language models in various domains for improving language understanding, automation, and interaction between humans and computers.
In this tutorial, we'll learn about how to build Model Context Protocol or the MCP Server. An MCP server acts as a bridge between local scripts and powerful AI interfaces, enabling dynamic command execution. This tutorial walks you through setting up your first MCP server, from basic configuration to running tools interactively. We will cover the MCP.json setup, writing Python tool functions, and connecting them to an AI layer. By the end, you will be able to build and serve your own tools, ready to be called as AI agents or co-pilots. Now, in today's session, we will actually work on one. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities like Purdue, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data companies and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher-paying job and profile. If you are interested in making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started. So, What exactly is a Model Context Protocol, or also known as the MCP? So the MCP is an open standard developed by Anthropic that aims to standardize how large language models integrate with external data, tools, and services. So external data can be a live website or a live data storage or a cloud server or anything like that. You just need to build an agent which can access that particular website or a data source and get real-time data for you and work for you as if you were actually doing it for yourself, right? In here, you develop an agent which works for you in your place. Now, let's go through the official documentation of MCP for more information on that. So this is the official Anthropic documentation for MCP. So MCP is the open source protocol that standardizes how applications provide context to LLMs. Think of MCP like a USB-C port for AI applications. So let's say you wanted to build an AI agent and you're doing it through an AI IDE like Cursor AI, right? You need to provide a type of prompt which will help it understand how to build it. In the same way, MCP acts like a common template where you can build your own prompt for explaining your AI agent what to do and how exactly to do it. Now here you have the various types of SDKs, software development kits, based on the programming language you're comfortable with. So here you can see we have C# or .NET SDK, Java SDK for programmers working in .NET. You have your dedicated one for the Java ones, you have Java. And similarly, we have Python, which we will be working on today. And here you have Ruby, Swift, and TypeScript. And apart from that, you have a quick start introduction to MCP, right? And you can also go through the documentation on how exactly it can help you for servers, client developers, cloud desktop users. And you also have some readily available servers as well as an example. And here you have the entirely accessible GitHub page for your MCP, which you can readily replicate in your IDs like Cursor AI or Visual Studio Code or any of the IDs that you prefer. And here you have the README files which you need to follow and a quick installation guide. You just need to run some commands on your command prompt like this one here. So this is my command prompt, and here you just need to use pip command pip3 install MCP. I've already installed it, so it'll just tell me that the required files are already installed. So here you can see already satisfied, right? So once your MCP is installed, you can get ahead with all the procedures here. So you can just refer to the README file. So here we have the Python file which is available here. Just let me explain that. So yeah, you have two README files, which is 3 months old and 2 weeks old. We'll go ahead with the one which is the latest one, which is 2 weeks old. So here you have the MCP Python SDK, which will help you follow all these steps and procedures, right? Now let's build a basic, MCP, which will help you understand how exactly MCP works, and you'll understand how to actually build one for yourself. Once you understand the foundation part, then you can go ahead with the advanced ones. So you can just open any of your IDs. I'm going with Cursor AI, and now I'll create a new file. Just go to new and create a new folder. We'll name it as MCP Server. Once created, just select that folder, which is our new folder that we will be working in. So that's a file, and here you just need to create a new code file for your Python code. So once we have created a new folder on MCP server name, we need to create a new code file for .py. So this will be named as first mcp.py. So I've already created a code document which we need to add here, which is a notepad. So we'll just copy paste this code over there. And this code is all about converting the US dollars to pounds sterling. So there's a small error, I think. That's the variable name, exchange rate. So I'll just paste it there so that we don't have errors. So basically what it does is it converts the US dollars to pounds. Let's say I give about $1. What's the price of $1? It'll convert $1 price into XYZ pound value. So we are importing the MCP here, and the next is where we are providing the tool name. And next we are importing the MCP tool, and here we are defining what exactly this particular MCP tool is doing. We are providing a fixed variable, and that particular variable will be used to calculate the amount that we input. Amount is the input that we will be giving from the user end. Let's say, for example, just we discussed about $1, right? You might give XYZ number of dollars and ask this particular MCP to convert that dollar amount to pounds. Now, let's go to, let's save it. Now, let's go to preferences, and here we will go to cursor settings, and here we have the MCP tools. So here we will create the MCP. You already have some MCPs from the previous examples. We'll erase this just a moment. So here now we will write MCP run first MCP.py. We need to copy the path and just paste it. Automatically, Cursor AI will create an MCP.json file for yourself, right? So there you see the recommendation from Cursor AI, right? You just need to press enter and the file will be ready for you. Okay, let's try that again. Yeah, now we have a fully functioning MCP file, .json file, right? Just again save everything and now go back to the home page. So the tool is not enabled. Sometimes it creates that small issue. All you need to do is just restart or disable and enable the MCP once again and you'll have it. So now go to the agent, save all and go to the agent. And now on the agent, you can just write a prompt. Can you convert $100 to pounds? Yes, using your current function, USD to GT. Okay, I think I gave, yeah. So we'll write on the prompt on the agent. Can you convert $100 to pounds? And there you go. It's generating the answer. Yes, your current function. And the answer is 79 GBP. So this is our answer and it will return 79. If you want to see this action in or need a script to print the result, let me know, right? Now we will proceed further and create another AI agent or MCP server which can find information about the provided term on the internet, right? That will be our real-time use case. And apart from that, so before we get started, if you wanted to create any other MCP server, which is not just searching for the information, or if you wanted to kind of find out the value of Bitcoin for today or any other cryptocurrency today, right? Or if you wanted to create an MCP server for investigating the stock prices, there is a procedure. So all you need to do is go to the official documentation that we have just referred, right? So this will be the official documentation. You can just copy this README file, right? So this is the one, yeah? This is the one. You just need to copy this README file and provide this to your MCP. So we'll create a new window. So now we are on the new window. All you need to do is just go to the preferences and here to the cursor settings. And here you got the option for indexing and docs. Previously, it was having a features option over here. And from features, you need to go to indexing and docs. Now the cursor AI has been updated. So you'll directly find this option over here, indexing and docs. And here you need to add that particular document link. Just add document link and Control V, and then you just need to enter and save it. But for now, I've already added that particular documentation over here. So you can see we have a Simplilearn Python SDK demo, which we will be using. And using that, you can just go to the command prompt and write the required project. So here, right? So you can just write the kind of requirement you're looking for, and you can tell the AI agent, look for the reference here, right? So let's go to open a new project. Just create a new one again. Sample. And here you can write the context, right? At the rate and docs. And here you will be having the doc which we created, right? Simplilearn Python. You can just provide this doc and give the command to your agent. And again, you can provide the agent as well. You can go ahead with automatic agent. It can choose any of the agents available. Or if you have a specific selection, you can just go ahead with any of the options provided here. Sonnet, or you can also go with ChatGPT 4.1 or Gemini, Flash, whatever the options available, you can go ahead with them. Yes, you can ask, all you have to do is just ask the agent about creating a kind of XYZ agent which will do XYZ job for you. And you can also provide some details like your API keys and everything. So which we will be working on now. Let's proceed further on the project. Let me close everything and get ahead with the project now. So our project will be based on exploring data on internet for the term Simplilearn. Now let's close everything and get started. So over to our demonstration. Let's get started. So as we discussed before, we will get started by installing Node.js into our operating system. So we're working on Windows operating system. So we might have to go ahead with Windows. So I'll choose Windows and the architecture will be the one which I'm working with. So that would be x64. But in case if you are working with a different operating system, say Mac OS, then you might have to select ARM or any suitable architecture that you can be compatible with. For Linux, you'll have to choose with the same and so on. So since we're working with Windows, so Windows it is and x64 architecture, and click on that Windows installer MSI file. So it will be getting started to install, and you'll have to click on that Windows installer.msi file and it'll get downloaded. While it is getting downloaded, let's go to the next web page and download and install the Cursor AI that we will be needing for this demonstration today. You'll have to log in, create an account and log in, and automatically it will give you the version that suits our operating system. Since we are in Windows, it gave me a Windows operating system. Just sign up or log in. So since you've already an account, just log into your account and confirm it's that you, and followed by that you'll have installed your Cursor AI. Choose your theme. I'll go with the Cursor Dark theme. And here you make sure that you have Cursor tab, Control K agent, and you can also choose the data sharing option. I'll go with the privacy mode in case if you want the other one, go ahead with that. And here you have a few review settings, and there you go. Now you're on the new window for Cursor AI. And meanwhile, let's check on the Node.js installation. I think the wizard has already started installing the Node.js setup. So this is the window. Let's quickly go through each and every instance that we have gone through so far in this particular window from the beginning. So it started off with some packages that we would be needing. So yeah, chocolatey and KB299. Yeah, further we have, and the last one is Python 13, right? Version 3.13.3 is approved. So far so good. I think we can now get started with the next step. So here we are on the Cursor AI. So we might have to get started going through the Cursor AI settings to create our new MCP. So there are quite a few methods that you can try out to reach to settings. One is you can go to the file and there you may have to choose the preferences, and then you have the Cursor settings. You just can use that particular step, or you can go ahead with the search options as well. So you can use that step, or you can also use the other step where you can just go to the search window and search for the settings. Here you can see MCP on the left window. So let me also walk you through a few other steps. So go to the search window and type down Cursor AI or Cursor settings. I think there has been a discrepancy, but not to worry. We'll go with the regular approach where we go to the file, preferences, and Cursor settings. And there you have the options on the left hand side. Go to MCP, and so far you don't have any MCP servers because this is the first time you've logged into Cursor AI. So you just have to add new global MCP server, which is available on the blue color button. Just click on that. And now you'll have a mcp.json file which is completely empty. You'll have to write down a few hard-coded codes here, which are not too complex related to the earlier ones that you have worked on in A10. So you might need a few more tools here. So go to the Firecrawl website. Before that, let's go through some awesome MCP servers GitHub link. So here we have almost all information related to the MCP. So let's open a new window and open all these links. What is MCP, clients, tutorials, community, legend, server implementations, framework, tips and tricks, right? For further information, you can go through all these web pages individually. So back to the home page, here you have everything you needed. The basic information of what exactly is MCP, and further you have some server implementations, Like if you scroll down, so you have awesome MCP service. This is where the beginning is. And next you have server implementations, aggregators, art and culture, coding execution, right? Customer data platforms. So here you have aggregators, art and culture, dedicated web spaces. So, and you have also cloud platforms that you can work along with. And moving further, you have code executions, coding agents, command lines as well, and communication related stuff. So you can go along and perform your operations, customer data or platforms, data platforms, and much more. Let's close all these windows and get started with the next stage where we need an API, right? So for that, the project that we're working on, which is web crawler, we will be needing an API from one of the providers, which is Firecrawl API. Okay, that's the one, Firecrawl MCP. So that's the one. Click on that particular link. Here, to generate an API, first you might have to sign up with Firecrawl. So before we sign up, let's go through the website of Firecrawl from the beginning. So that's the template code that you'll be working on. And also here we have a wide variety of crawl options, media parsing options, smart weight actions, right? Reliability first and all those things. And also we have the pricing details. For now, we'll go ahead with the free plan. And yeah, let me add down my details, my email address, and you might also have to add a password. So let me type down something. Yeah, so the password is not too strong enough. That's a good thing. They have a really strong website. So that's a sign you need to have strong passwords, and also make sure that you don't share your passwords and the API keys that you generate using Firecrawl. Now that my password is a little too longer, I think it should be access. Yeah, it's accessible and it is a successful account generation. Now you need to check your email and confirm that login credentials are right and everything. So once you are signed up, let's go through another website for generating our API keys. So Firecrawl API, scroll a little bit. So API documentation. So here you'll find some documentation related to Firecrawl and all the details that you need to go through for API key generation. So Firecrawl MCP Server. Yeah, that's the website that we're looking for. Firecrawl MCP Server. That's the one. And here you have overview, content, tools, and other resources that you're looking for. Now, this is the template server configuration that you'll be needing. So make sure that you have an eye on it. And now you will also have the details that you might have to go through. Like basically, it'll have the steps that you need to follow in the content page. Click on content. There you go. So it has all the features and details that you need to go ahead with. And tools, you have the crawling, extraction, scraping tools that you can work along with Firecrawl, and a few comments here. Now, yeah, the email has not been confirmed yet. Let's try to resend and reconfirm the email so that we just sign up or log in and create our API keys as soon as possible. So there you go. I have verified my email in my phone. So I'll just enter the credentials and sign in. Successful, you are signed in. On the left hand side, you can see the overview, playground, extract, activity logs, usage, API keys, and all the settings. So here you can see my API key has been by default hidden, so I'll not visualize it now. So you have two options, either view or copy. So we will be copying it for the first time to be on the safe side. So since we are new to this particular website, so we don't have any activities registered on this particular web page. So now we have the API keys. Now let's go to the content page to verify the steps that we need to follow. So we need to install npm and we need to go to the Cursor AI settings and add a new MCP server, which we already did. So we just need to copy the template code and we just need to place it there. And also, don't worry about where exactly to place your API keys in the template. We have that place. So we are back on the Cursor AI. Now we will replace this template code with the code that we just copied. And remember, if you're using Windows, try cmd/c. Okay. If you're not on Windows, you can eliminate that cmd/c. But if you are working in Windows, then you definitely need that cmd/c. Okay, let's erase this and replace that. So I'll name my tool as Fire Crawl, and I'll go to the new line where I'll write down my command, and the command will be the code that I just copied from the Firecrawl window. So let me type down the command in double quotes in the new line, and I'll paste the command here, which is the code that we copied from the Firecrawl window. Control V. There you go. So the white stuff which is in CMD/C, so that's the one you need to focus on. If you are working on Windows, that you definitely need it. If you're not working on Windows, then you can just omit it. Now, there might be some concerns with the codes, don't worry. Now, to cross-verify, you can just go back to the Firecrawl homepage and cross-verify it with the template for configuration that they have made us available. Let's go back to the Firecrawl window, and at the same time, you can see your API key here. So that's where you need to place your API key. So here we are on the Firecrawl window. You need to copy the API key and place it in the place where they have mentioned your API key. So if you have cross-verified with the configuration code, that's fine. And now you can just check the double quotes. So that's the one you need to focus on. Let me if there is a way to zoom it in, let me try to zoom in. Yeah, that's the one, CMD/C. If you're on Windows, you definitely need this. If you're not on Windows, you can just choose to omit it. Now let me just do one last final check. I think I missed a double quote somewhere. Yeah, I need to remove it from this place and add it to the end. Just a second. Okay, remove the double quote at that place. Now it should be after MCP. And once everything is done, you can just quickly choose to save and close this particular window. Check the distance between the API key and the double ampersand places. That's fine. And saving is really simple. Choose those three dots, close, save. And once that is clicked, it's all done. You get to choose to close this particular mcp.json file and get back to your agent. So once you have closed it, you will have your new server that you've just created in the cursor settings. But in a few times you get no tool connected, no server connected, or there might be some errors. So in that case, you just need to cross-verify the npm installation, Node.js installation, and check all the files that are there or not. But even if everything is installed and you can see the versions available, and if you're still seeing this or watching that particular error, then don't worry, just close the cursor AI and restart it, or you can also choose the refresh option, which is right available there. So I've closed and restarted it, and the same procedure, go to File, Preferences, Cursor Settings, and there you'll see the MCP models, and there you'll find it right there, correct? Now close it and go to the window where you'll find the server. Yeah, that's the one. And here you choose the agent. Make sure that you choose the agent instead of anything else. Not manual, not ask. I choose the agent. And now I'll write down a simple prompt. Search for Simplilearn on Google. Now it should give me results which it finds on Google. Maybe it's a home page, maybe it's a social media handle like LinkedIn or YouTube or Instagram, anything that it finds related to Simplilearn. Only the term Simplilearn. So here you can see it has given me 3 different results. First one is Simplilearn website. Second one is Simplilearn YouTube channel, and the third one is LinkedIn page. So let's get started with the official web page. So click on the simplilearn.com. Now, it's asking me permission, open. Now we are on Simplilearn homepage. Similarly, let's go back and select for the YouTube page. So that's the one. Open again, get permissions. So you're on the Simplilearn YouTube page. Now I think it might ask for a login for LinkedIn. But anyways, let's try to check if it can open without logging in to LinkedIn or not. So yeah, you can see I've logged in to the YouTube. Yeah, it is asking me to log in. So let's quickly log in. It might take a couple of seconds. So there you go. I've logged into LinkedIn. Now open. So I can see Simplilearn's homepage getting loaded in a second. Yeah, there you go. On LinkedIn, we have opened the Simplilearn's homepage successfully.
Today, we will discuss about booming topic of this era, multimodal AI. Let's understand with an example. Imagine you are showing a friend your vacation photos. You might describe the sight you saw, the sounds you heard, and even your emotions. This is how humans naturally understand the world, by combining information from different sources. Multimodal AI aims to do the same thing. Let's break the modal AI first. Multimodal refers to the 2 different ways of communicating information like text, speech, images, and videos where AI stands for artificial intelligence, which are systems that can learn and make decisions. So multimodal AI is a type of AI that can process and understand information from multiple sources, just like you do when you look at your vacation photos. Now that we have understood what is multimodal AI, let's now go a bit further. It is obvious that multimodal AI is not the only AI out there. But what is big deal about multimodal AI that everyone is talking about? That is what we will discuss in this segment. So now let's understand the difference between multimodal AI and the generative AI. While both multimodal AI and generative AI are exciting advancement in AI, they differ in their approach to data and functionality. So generative AI focus creates new data similar to the data it's trained on. And in multimodal AI, focus is to understand and processes information from multiple sources, that is text, speech, images, and videos. Data types of generative AI are primarily works with a single data type like text, writing poems or images, that is generating realistic portraits. Whereas in multimodal AI, data types works with diverse data types, enabling a more comprehensive understanding of the world. The third one is examples like chatbots, text generation models, image editing tools. Whereas multimodal AI example covers virtual assistants, medical diagnosis system, and autonomous vehicles. Strengths are can produce creative and innovative content, automate repetitive tasks, and personalize your experience. Whereas in multimodal AI, strengths are provides a more human-like understanding of the world and improve accuracy. In essence, generative AI excels at creating new data, while multimodal AI excels at understanding and utilizing existing data from diverse sources. They can be complementary, with generative models being used to create new data for multimodal AI systems to learn more from and improve their understanding to the world. Next, let's understand what are the benefits of multimodal AI. The benefits of multimodal AI is that it offers developers and users an AI with more advanced reasoning, problem solving, and generation capabilities. These advancements offers endless possibilities for how next generation application can change the way we work and live. For developers looking to start building, Vortex AI Gemini API offers features such as enterprise security, data residency, performance, and technical support. If your existing Google Cloud customers can start prompting with Gemini AI in Vortex AI right now. Next, let's see what are the multimodal AI big challenges. Multimodal AI is powerful but faces hurdles. The first one is data overload. Managing and storing massive, diverse data is expensive and complex. The second one is meaning mystery. Teaching AI to understand subtle difference in between meaning like sarcasm is tricky. The third one is data alignment. Ensuring data points from different sources staying in tune is challenging. The fourth one is data scarcity. Limited and potentially biased datasets hinder effective training. The fifth one is missing data blues. What happens when data is missing, like distorted audio? The last one is black box blues. Understanding how AI makes decisions can be difficult. So these challenges must be addressed to unlock the full potential of model AI. Next, let's see what is the future of multimodal AI and why is it important. Multimodal AI and multimodals represent a leap forward in how developers build and expand the functionality of AI in the next generation of application. For example, Gemini can understand, explain, and generate high quality code in the world's most popular programming languages like Python, Java, C++, and Go, freeing developers to work on building more featured field applications. Multimodal's AI potential also bring the world closer to AI that's less like smart software and more like an expert helper or assistant.
Why reinforcement learning? Training a machine learning model requires a lot of data, which might not always be available to us. Further, the data provided might not be reliable. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. You can see here we have the robot learning to walk. Very complicated setup when you're learning how to walk, and you'll start asking questions like, if I'm taking one step forward and left, well, what happens if I pick up a 50-pound object? How does that change how a robot would walk? These things are very difficult to program because there's no actual information on it until it's actually tried out. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. And we'll see here it learned how to walk. This is going to slow at a solution by itself, the robot destination. It will know the best path by the time taken on each path. It might even come up with a unique solution all by itself. And that's really important as we're looking for unique solutions. We want the best solution, but you can't find it unless you try it. So when we're looking at our different systems, our different model, we have supervised versus unsupervised versus reinforcement learning. And with the supervised learning, that is probably the most controlled environment. We models, whether it's linear regression, neural networks, there's all kinds of things in between, decision trees. The data provided is labeled data with output values specified. And this is important because when we talk about supervised learning, you already know the answer for all this information. You already know the picture has a motorcycle in it. So you're supervised learning. You already know that the outcome for tomorrow, for going back a week, you're looking at stock, you can already have like the graph of what the next day looks like, so you have an answer for it. And you have labeled data which is used, you have an external supervision, and solves problems by mapping labeled input to known output. So very controlled. Unsupervised learning, and unsupervised learning is really interesting because it's now taking part in many other models. They start with you can actually insert an unsupervised learning model in almost either supervised or reinforcement learning as part of the system, which is really cool. Data provided is unlabeled data. The outputs are not specified. Machine makes its own predictions. Used to solve association with clustering problems. Unlabeled data is used. No supervision. Solves problems by understanding patterns and discovering output. So you can look at this and you can think some of these things go with each other. They belong together. So it's looking for what connects in different ways. And there's a lot of different algorithms that look at this. When you start getting into those, there's some really cool images that come up of what unsupervised learning is. How it can pick out, say, the area of a donut. One model will see the area of the donut, and the other one will divide it into 3 sections based on its location versus what's next to it. So there's a lot of stuff that goes in with unsupervised learning. And then we're looking at reinforcement learning. Probably the biggest industry in today's market in machine learning, or growing market. It's very infant stage as far as how it works and what it's going to be capable of. The machine learns from its environment using rewards and errors. Used to solve reward-based problems. No predefined data is used. No supervision. Follows trial and error problem solving approach. So again, we have a random, at first you start with a random, I try this, it works, and this is my reward. Doesn't work very well maybe, or maybe it doesn't even get you where you're trying to get it to do, and you get your reward back, and then it looks at that and says, well, let's try something else, and it starts to play with these different things, finding the best route. So let's take a look at important terms in today's reinforcement model. And this has become pretty standardized over the last few years, so these are really good to know. We have the agent. Agent is the model that is being trained via reinforcement learning. So this is your actual entity that has, however you're doing it, whether you're using a neural network or a Q table or whatever, combination thereof. This is the actual agent that you're using. This is the model. And you have your environment. The training situation that the model must optimize to is called its environment. And you can see here, I guess we have a robot who's trying to get a chest full of gems or whatever, and that's the output. And then you have your action. This is all possible steps that can be taken by the model, and it picks one action. And you can see here that it's picked 3 different routes to get to the chest of diamonds and gems. We have a state, the current position condition returned by the model. And you could look at this if you're playing like a video game. This is the screen you're looking at. So when you go back here, the environment is a whole game board. So if you're playing one of those Mobius games, you might have the whole game board going on, but then you have your current position. Where are you on that game board? What's around that? What's around you? If you were talking about a robot, the environment might be moving around the yard, where it is in the yard and what it can see, what input it has in that location. That would be the current position condition returned by the model. And then the reward. To help the model move in the right direction, it is rewarded. Points are given to it to appraise some kind of action. So yeah, you did good, or if didn't do as good, trying to maximize the reward and have the best reward possible. And then policy. Policy determines how an agent will behave at any time. It acts as a mapping between action and present state. This is part of the model. What is your action that you're going to take? What's the policy you're using to have an output from your agent? One of the reasons they separate policy as its own entity is that you usually have a prediction of a different options, and then the policy, well, how am I going to pick the best? Based on those predictions, I'm going to guess at different options, and we'll actually weigh those options in and find the best option we think will work. So it's a little tricky, but the policy thing is actually pretty cool how it works. Let's go ahead and take a look at a reinforcement learning example. And just in looking at this, we're going to take a look, consider what a dog that we want to train. So the dog would be like the agent. So you have your puppy or whatever. And then your environment is going to be the whole house or whatever it is where you're training them. And then you have an action. We want to teach the dog to fetch. So action equals fetching. And then we have a little biscuit, so we can get the dog to perform various actions by offering incentives such as a dog biscuit as a reward. The dog will follow a policy to maximize this reward, and hence will follow every command and might even learn new actions like begging by itself. So you have, so we start off with fetching. It goes, oh, I get a biscuit for that. It tries something else, and you get a handshake or begging or something like that. And it goes, oh, this is also reward based. And so it kind of explores things to find out what will bring it as biscuit. And that's very much like how a reinforced model goes. Is it looks for different rewards. How do I find? Can I try different things and find a reward that works? The dog also will want to run around and play and explore its environment. This quality of model is called exploration. So there's a little randomness going on in exploration. And it explores new parts of the house. Climbing on the sofa doesn't get a reward. In fact, it usually gets kicked off the sofa. So let's talk a little bit about Markov's decision process. Markov's decision process is a reinforcement learning policy used to map a current state to an action where the agent continuously interacts with the environment to produce new solutions and receive rewards. And you'll see here's all of our different vocabulary we just went over. We have a reward, our state, our agent, our environment, and our action. And so even though the environment kind of contains everything, that you really, when you're actually writing the program, your environment's going to put out a reward and state that goes into the agent. The agent then looks at this state, or it looks at the reward usually first, and it says, okay, I got rewarded for whatever I just did, or I didn't get rewarded. And then it looks at the state, and then it comes back, and if you remember from policy, the policy comes in, and then we have a reward. The policy is that part that's connected at the bottom. And so it looks at that policy and it says, hey, what's a good action that will probably be similar to what I did, or sometimes they're completely random, but what's a good action that's going to bring me a different reward? So taking the time to just understand these different pieces as they go is pretty important in most of the models today. And so a lot of them actually have templates based on this you can pull in and start using. Pretty straightforward as far as once you start seeing how it works, you can see your environment says, hey, this is the agent did this. If you're a character in a game, this happened, and it shoots out a reward in a state. The agent looks at the reward, looks at the new state, and then takes a little guess and says, I'm going to try this action. And then that action goes back into the environment. It affects the environment. The environment then changes depending on what the action was, and then it has a new state and a new reward that goes back to the agent. So in the diagram shown, we need to find the shortest path between node A and D. Each path has a reward associated with it, and the path with a maximum reward is what we want to choose. The nodes A, B, C, D denote the nodes to travel from node A to B is an action. Reward is the cost of each path, and policy is each path taken. And you can see here A can go to B, or A can go to C right off the bat, or it can go right to D. And if we explored all three of these, you would find that A going to D was a 0 reward, A going to C and D would generate a different reward, or you could go A, C, B, D. There's a lot of options here. And so when we start looking at this diagram, you start to realize that even though today's reinforced learning models do really good at finding an answer, they end up trying almost all the different directions you see. And so they take up a lot of work or a lot of processing time for reinforcement learning. They're right now in their infant stage, and they're really good at solving simple problems. And we'll take a look at one of those in just a minute in a tic-tac-toe game. But you can see here, once it's gone through these and it's explored, it's going to find the A, C, D is the best reward. It gets a full 30 points for it. So let's go ahead and take a look at a reinforcement learning demo. In this demo, we're going to use reinforcement learning to make a tic-tac-toe game. You will be playing this game against the machine learning model. And we'll go ahead, and we're doing it in Python. So let's go ahead and go through, not always, I actually have a lot of Python tools. Let's go through Anaconda, which will open up a Jupyter notebook. Seems like a lot of steps, but it's worth it to keep all my stuff separate, and it also has a nice display when you're in the Jupyter notebook for doing Python. So here's our Anaconda navigator. I open up the notebook, which is going to take me to a web page, and I've gone in here and created a new Python folder. In this case, I've already done it and enabled it to change the name to tic-tac-toe. And then for this example, we're going to go ahead and import a couple things. We're going to import numpy as np. We'll go ahead and import pickle. Numpy, of course, is our number array, and then pickle is just a nice way sometimes for storing different information, different states that we're going to go through on here. And so we're going to create a class called state. We're going to start with that. And there's a lot of lines of code to this class that we're going to put in here. Don't let that scare you too much. There's not as much here. It looks like there's going to be a lot here, but there really is just a lot of setup going on in our class state. And so we have up here, we're going to initialize it. We have our board. It's a tic-tac-toe board, so we're only dealing with 9 spots on the board. We have player 1, player 2 is end. We're going to create a board hash. We'll look at that in just a minute. We're just going to store some information in there. Symbol of player equals 1. So there's a few things going on as far as the initialization. Then something simple, we're just going to get the hash of the board. We're going to get the information from the board on there, which is columns and rows. We want to know when a winner occurs, so if you get 3 in a row, that's what this whole section here is for. Let me go ahead and scroll up a little bit. And you can get a copy of this code if you send a note over to Simplilearn. We'll send you over this particular file, and you can play with it yourself and see how it's put together. I don't want to spend a huge amount of time on this because this is just some real general Python coding. But you can see here we're just going through all the rows, and you add them together, and if it equals 3 in a row, same thing with columns. Diagonal, so you got to check the diagonal. That's what all this stuff does here, is it just goes through the different areas. Actually, let me go ahead and put, there we go. And then it comes down here and we do our sum, and it says true, -3 just says did somebody win or is it a tie. So you got to add up all the numbers on there anyway, just in case they're all filled up. And next we also need to know available positions. These are ones that no one's ever used before. This way when you try something or the computer tries something, it's not going to give it an illegal move. That's what the available positions is doing. Then we want to update our state. And so you have your position going in. We're just sending in the position that you just chose. And you'll see there's a little user interface we put in there. You can pick the row and column in there. And again, I mean, this is a lot of code. So really it's kind of a thing you'd want to go through and play with a little bit and just read through it, get a copy of it. A great way to understand how this works. And here is a given reward. So we're going to give a reward, result equals self winner. This is one of the hearts of what's going on here, is we have a result self.winner. So if there's a winner, then we have a result. If the result equals 1, here's our feedback. If it doesn't equal 1, then it gets a 0. So it only gets a reward in this particular case if it wins. And that's important to know because different systems of reinforced learning do rewarding a lot differently depending on what you're trying to do. This is a very simple example with a 3x3 board. Imagine if you're playing a video game, certainly you only have so many actions, but your environment is huge. You have a lot going on in the environment, and suddenly a reward system like this is going to be just is going to have to change a little bit. It's going to have different rewards and different setup. And there's all kinds of advanced ways to do that as far as weighing. You add weights to it, and so they can add the weights up depending on where the reward comes in. So it might be that you actually get a reward. In this case, you get the reward at the end of the game. And I'm spending just a little bit of time on this because this is an important thing to note. But there's different ways to add up those rewards. It might have, like if you take a certain path, the first reward is going to be weighed a little bit less than the last reward because the last reward is actually winning the game or scoring or whatever it is. So this reward system gets really complicated in some of the more advanced setups. In this case, though, you can see right here that they give a 0.1 and a 0.5 reward just for picking the right value and something that's actually valid instead of picking an invalid value. So rewards, again, that's like key. It's huge. How do you feed the rewards back in? Then we have a board reset. That's pretty straightforward. It just goes back and resets the board to the beginning because it's going to try out all these different things while it's learning. It's going to do it by trial and error, so you have to keep resetting it. And then, of course, there's the play. We want to go ahead and play rounds equals 100. Depends on what you want to do on here. You can set this different. You can obviously set that to higher level. But this is just going to go through, and you'll see in here that we have player 1 and player 2. This is the computer playing itself. One of the more powerful ways to learn to play a game, or even learn something that isn't a game, is to have two of these models that are basically trying to beat each other. And so they keep explore new things. This one works for this one, so this one tries new things. It beats this. We've seen this in chess. I think was a big one where they had the two players in chess with reinforcement learning. It was one of the ways they trained one of the top computer chess playing algorithms. So this is just what this is. It's going to choose an action. It's going to try something, and the more it tries stuff, the more we're going to record the hash. We actually have a board hash where you self get the hash set up on here where it stores all the information. And then once you get to a win, one of them wins, it gets the reward. Then we go back and reset and try again. And then kind of the fun part we actually get down here is we're going to play with a human. So we'll get a chance to come in here and see what that looks like when you put your own information in. And then it just comes in here and does the same thing it did above. It gives it a reward for its things, or sees if it wins or ties, looks at available positions, all that kind of fun stuff. And then finally we want to show the board. So it's going to print the board out each time. Really, is not that exciting. What's exciting in here is, one, looking at this reward system. Whoops, play one more up. The reward system is really the heart of this. How do you reward the different setup? And the other one is when it's playing, it's got to take an action. And so what it chooses for an action is also the heart of reinforcement learning. How do we choose that action? And those are really key to right now where reinforcement learning is in today's technology, is figuring this out. How do we reward it, and how do we guess the next best action? So we have our environment, and you can see the environment is or the state, which is kind of like what's going on. We're going to return the state depending on what happens. And we want to go ahead and create our agent, in this case our player. So each one is, let me go and grab that. And so we look at a class player. This is where